Welcome to this Fundamentals Lesson Plan series on stairs and railings, layout and design. In this video, we'll take a look at creating straight run stairs in a project context. This is video 1 of 4. My name is John Harridge, and I will be your host for today's lesson. Let's look at the learning objectives for video 1. At the end of this lesson, you will be able to create a straight run stair using the stair by sketch method. And then through that sketch, you'll be able to modify it and also convert that to a model-based element. With that, let's begin. Let me begin with an instructor-only demo in a new project file so I can cover the key concepts of creating stairs in Revit prior to proceeding with the hands-on exercises. So if you would, just please watch and listen while I go over these key concepts, and then I'll let you know when to jump in for the hands-on exercises. Stairs in Revit are a type of systems family component, and what I mean by that is that they are created in Revit project files and live inside Revit project files. So if we scroll down in the project browser window and open up the families folder, you'll note that there are several stair style types listed in there. That's what I mean by living inside of a project file. However, some of the subcomponents used in stairs are indeed loadable families like balusters and railing profiles. So if you go to the Insert tab and click on Load Family, I'll show you where those components live. Now you'll notice on the surface that there are no stair folders. So the only thing that we can work with that looks reasonable here are profiles. So if we open up the Profiles folder, we will find a subdirectory for stair components. And this ranges anything from handrail profiles to stair treads and riser profiles. So I won't load any of those in, but I just want to let you know where they're located. All right, so where are the circulation tools found? They are located on the Architecture tab. So I'm going to go ahead and select that. And then you'll notice just to the right of the Build panel is the Circulation panel, where you'll find the stair tools. So there's actually two stair tools now. There's stairs by component. That's not part of this exercise. And the other is stair by sketch, and that's the one that we're going to take a look at. All right, so I'm just confirming that the level 1 plan view is the current view. And if I left click to start the stair tool, I just want to let you know that stairs are constraint based. So what I mean by that is they start at a level and they end at a level as a target. And so maybe to make this a little bit more compelling, I'll open up the south elevation view so that we can see both the plan view and an elevation view simultaneously on the screen. Let me make the plan view the current view, and then I'll tile the windows to be current on the screen. So I have the plan view on the left, and I have the elevation view on the right. So to make this meaningful, let me go ahead and create a context wall to work from to place and locate a stair. And let me just tighten up the elevation datums here. And I'll zoom into the plan view. All right, so kind of starting the workflow again, Architecture tab, click on the pull down menu for the stair tool. I'm going to start the stair by sketch tool. And again, just letting you know this constraint based, so I'm starting from level 1 and I'm going to end at level 2. So to begin, to lay out the stairs, you left click in the canvas window to set a start point, which is actually the bottom of the stairs. And then as I drag my cursor to the right, you'll notice that the cursor jumps to a particular snap interval, and that's actually predetermined by the stair style in terms of the stair calculation rules in terms of what's the tread depth. The other purpose for moving your cursor is to set the direction of the stairs. Now, when I left click beyond the bounding box, it does take me into a sketch environment, and the first line type that you'll see is the run line type. The second is the riser line type that's indicated in black, and last is the boundary line type that's shown in green. So all three of those need to work together to create a composite sketch in order to convert that to a 3D element. So you'll notice that stairs are sketch based, and so to convert the sketch to a 3D element, you would click Finish Edit Mode, and it generates the 3D stair element in all model views. So if I hover on the stair part of it and left click to put it in a selection set, you can see it highlight in the elevation view, and likewise with the railing component. Now to edit stairs, it's as simple as putting the stairs in a selection set and then choosing the Edit Sketch command. That takes us back into the sketch environment mode, and I can make changes as need be for my project. In this case, maybe we'll make a simple change. We'll just change the width of the stairs. I'll go ahead and select this boundary line here and move it down a foot or so, just using the Move tool. And note that the riser line work does not follow the boundary tool, but that's okay. And it's not important to, or not necessary to, repair the riser line work to meet that boundary. Revit will take care of that. So to convert that back to an element, I'll choose Finish Edit Mode, and there I have the updated three-dimensional stairs. Next, let's take a look at presetting some information. You'll notice that when you start the stair tool, it takes you by default into the run mode, which means you pick a start point, end point on screen. We also have the ability to specify which railing type is placed on the stairs. So if you click on railing and then choose your railing style, you can choose to place it either on a tread or on the stringer. I'll go ahead and choose stringer in this case. And I'll place another instance of a stair. So just dragging beyond the stair boundary, which represents the extents of the stair from level 1 to level 2. I'll go ahead and left click to Finish Edit Mode, and you'll notice that I have a different railing type now appearing on the stairs. Let me go ahead and delete that example. Let's take another look here. Now in this case, if you wanted to create a landing situation, you would just place 2 points, and the second point being internal to the stair boundary allows me to acquire a midpoint snap for the width of the stairs, or I'll call it a full snap to have the landing be the same length as the width of the stairs. And then just by left clicking outside the boundary of the stairs, I can actually complete that stair sketch as intended, and then click Finish Edit Mode to generate the stairs. So let's take a look at the second floor plan view, and let me take a look at this question in terms of what happens, what's the reaction between stairs and floor elements And I'm just going to quickly sketch out a floor plate here that overlaps the stairs. And then I'll go ahead and open up a 3D view. I just want to demonstrate that stairs do not automatically create openings in the floor element. So there's actually 2 ways to address this. So let me get back into a context where I can actually edit the floor and still see the overall length of the stair footprint, if you will, from the 2nd floor. So I was setting level 1 as an underlay, and then maybe using the wireframe display mode, I'll be able to see that footprint. All right, so one approach is to actually select the floor element and add a new internal boundary sketch that's closed that matches the footprint of the stairs, and then accept that, and it will actually create an opening in that floor boundary. So that's one approach, and that's fine if you just have, a single floor to traverse. But if you want to use this concept with a multi-story building like a skyscraper or another commercial type building, then you might want to take a look at a shaft opening. That would be a good choice for this situation. So the shaft opening tool can be found in the opening panel on the architecture tab. It's sketch-based object as well, so I'll use a rectangle mode and sketch a closed boundary over the footprint of the stairs. Note that shaft openings are constraint based, so they have a starting level and either a user specified height or a target level. So what's highlighted in blue there on screen is the shaft opening, and I'll select the same object in the 3D view and maybe even change its height after the fact. So with that concludes this instructor demo. Now let's move on to the hands-on exercise. Okay, if you would please open an existing exercise file. Go ahead and click open and navigate to your tutorial directory. And please open the Stairs 01 exercise file. So the purpose of this exercise is to look at the stair by sketch placement technique for creating stairs, and we're going to do this in the lobby space here in this floor plan. And we're basically going to go from the entrance level to level 2 as a straight run stair with no landing. So just to understand the challenge here, open up the lobby stair 3D view, and again we're going to start with the base of the stair at the entry level, and we're going to stop at the 2nd floor plate. All right, to begin the layout process, go ahead and open up the level 1 floor plan view. Go ahead and zoom into the lobby area of the building plan. To help set the context for layout, we're going to modify the view properties for level 1 and bring in level 2 as an underlay so we know exactly where the floor boundary edges are. And you can see those ghosted in the lobby plan view. Next, let's go ahead and locate the stair by sketch tool. Again, left click on the architecture tab, and then you'll find the circulation panel just to the right of the build panel. Left click on the pull down menu for stairs. Stair by component is the new one. We're going to take a look at the original one. Go ahead and select stair by sketch. It has its own sketching based tool sets. We're using the run mode, which means it only takes 2 points to define the start and end point for the stair, and we're going to create a straight linear stair. So again, approximately at this location is where we're going to start the stair, but before we do that, let's take a look first at the properties palette. Again, just letting you know that we're starting from level 1 at the bottom of the stair, and the top of the stairs will end at level 2. So just above the double doors there, as best you can, go ahead and left click to set the start point for the stair, and then notice that the cursor snaps to intervals of the tread depth as you move up. Go ahead and place your cursor outside the boundary of the stair and left click to accept that direction and to complete the stair. And you'll note that the stair calculator lets you know how many risers were created and if there was any risers remaining to actually meet the level 2 elevation if you had an incomplete sketch. This is a sketch mode, so to close out, click on Finish Edit Mode, and it will generate the 3D stairs. So just to confirm progress, let's go back and return to the lobby stair 3D view. And there you go. Go ahead and hit the escape key twice to end the command. And let's perform a file save as to maintain progress. And give it the name Stairs 01 exercise finished. This concludes this exercise. Go ahead and click save after you give it a name, and then we'll take a look at next steps. Let's review the learning objectives for video 1. In this lesson, you were able to create a stair sketch using the stair by sketch method, and then we used the run technique to specify a start point and an end point. We then converted the stair sketch to a 3D stair element. With that, let's take a look at Autodesk resources that are available to you. I would like to make you aware of two specific Autodesk resources. The first one being the Autodesk Education Community, where you can access free software for both students and educators, and that can be located at www.students.autodesk.com. It does require registration, and you can use either your own personal email address or a school-issued email address. The second resource is the Autodesk Digital STEAM Workshop. It's hands-on, project-based learning across multiple industries such as architecture, engineering, gaming, and animation. And those resources are located at www.digitalsteam.autodesk.com. This concludes this exercise. Thank you very much for watching.